Hello, in this lecture we'll find out the value of x using two different methods. In the drawing we have a quarter circle. FAE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, you know that this is line segment DE that is equal to 12 units in its length. This is angle EDC is equal to theta, and this is angle EDC that is also equal to theta. Repeat again, our mission is to find out the length of this line segment DG that is equal to x. DG equals to x. So let's start with the first method. Because of the fact that ABCD is a square, all the angles inside this square are right angles. So this angle equals to 90 degrees in its size. This angle also equals to 90 degrees in its size. This angle equals to 90 degrees. And finally, this angle also equals to 90 degrees in its size. So here we know that angle CDA equals to 90 degrees. This is angle theta, and therefore the missing angle, that is also angle ADE, must be equal to the big angle that is 90 degrees minus theta. So the missing angle ADE must be equal to 90 degrees minus theta in its size. Okay. So in the next step we'll extend line segment GD and line segment EA by straight line until they touch each other. And we'll define their touching point, this point, as H. We'll extend also side CD of the square ABCD by straight line. Define this point as F. So in this drawing we have those two angles that are defined as vertex angles, and you know that vertex angles are equal to each other. But this angle equals to theta, therefore this angle must be also equal to theta. CD is a straight line because it is one side of square ABCD. We extended the straight line CD by straight line. The result is CF, that must be also a straight line, because when you extend the straight line by straight line, the result must be a straight line. So CF is a straight line. If we focus on the lower side of the straight line CF at point D, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of those two angles must be equal to 180 degrees in their sizes. So each angle we have at the lower side of CF at point D, we have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of the straight line CF at point D to 180 degrees, this missing angle must be equal to 90 degrees in its size. So the big angle FDA equals to 90 degrees. This angle equals to theta, therefore the missing angle, that's actually angle ADH, must be equal to 90 degrees minus theta. In the next step, we'll prove that those two right triangles congruent to each other. Repeat again. The next step we prove that those two right triangles congruent to each other. That is to say, the right triangle ADH congruent to the right triangle ADE. But before that, BA is one side of square ABCD, therefore it is absolutely a straight line. We extended the straight line BA by straight line, the result is BH. BH must be also equal, must be a straight line. So if you focus on the upper side of the straight line BH at point A, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of BH at point A, we have this angle that is 90 degrees, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So in the next step, we prove that those two right angles can go into each other. So I write it down. We prove that the right triangle ADH, this right triangle, congruent to this right triangle, triangle ADE. So why those two right triangles can go into each other? First of all, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, this is angle ADH in the right triangle ADH. And it is equal to this angle, this is actually angle ADE in the right triangle ADE. Repeat again. Angle ADH in the right triangle ADH equals to angle ADE in the right triangle ADE. They are both equal to 90 degrees, therefore they are equal to each other. In addition, DA is a common side that belongs to both triangles, so I can write down that DA equals to itself. Repeat again. DA equals to itself is a common side that belongs to both triangles. And finally, actually, I made a mistake here. Angle ADH equals to 90 degrees, and it is equal to angle ADE that is also equal to 90 degrees minus theta. Both angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle ADH equals to angle ADE, they are both equal to 90 degrees minus theta, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle HAD in the right triangle ADH, and it is equal to this angle, this is actually angle EAD. In the right triangle, triangle ADE. So I repeat again. Angle HAD in the right triangle ADH is equal to angle EAD in the right triangle ADE. They are both equal to 90 degrees, therefore they are equal to each other. So we actually proved that the right triangle ADH congruent, this is the sign of congruent, to the right triangle ADE according to angle side angle rule. So, what is angle side angle rule? Actually, if you prove that one triangle, the two angles and the side that is included between the two angles in one triangle are correspondingly equal to two angles and the side that is included between the two angles in a second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And here we proved that those two angles that are 90 degrees one theta and 90 degrees and the side that is included between those two angles that is side DA in the right triangle ADE are correspondingly equal to those two angles that are also 90 degrees one theta and 90 degrees. And the side that is included between those two angles, that is actually the same side DA in the right triangle ADH. Now we actually proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. And again, we conclude that D equals to DH. According to the rule, the corresponding sides in right triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say DE and DH, must be also equal to each other. But D equals to 12 according to what is given as the question. So we can write here that DE equals to 12. And from this equation, 12 equals to DE equals to DH, we derive that DH also equals to 12 units in its length. Here, DH equals to 12 units in its length. Likewise, according to the same rule that corresponding angles and congruent triangles are equal to each other, we will derive that side EA in the right triangle ADE is equal to side edge A in the right triangle ADH. And again, A equals to edge A according to the same rule. But what is the definition of side AE or line segment AE? Line segment AE is, of course, the radius of this quarter circle. We define the radius of this quarter circle as R, and therefore AE equals to R according to our definition. So we can write here that AE equals to R, and from this equation R equals to AE equals to HA, we derive that HA also equals to R. Okay, here HA equals to R. Okay, so in the next step, we'll join points G and D together by a straight line, those 2 points. By joining point G and D, we create a triangle edge GE. This is triangle edge GE, and we will join points G and A together by a straight line. So what is the definition of line segment GA? Line segment GA starts from point A, that is the center of the quarter circle, and at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of the quarter circle, that is equal to R. So, actually, because of the fact that this is point A, that it is located in the same distance from all the three vertices of triangle HGE. Therefore, point A is defined as the circumcenter of triangle HGE. We'll explain what I mean. So, first of all, I'll write it down. Point A is the circumcenter of triangle HGE. Why point A is the circumcenter? Here, of triangle HGE, the distance between point A and the vertex edge of triangle HGE is R. Likewise, the distance of point A from the vertex G is also R, and finally, the distance of point A from the vertex E of triangle HGE is also R. So point A is located in the same distance of the three vertices of triangle HGE, that are the edge G and E, and the distance is R. And therefore, point A is defined as the circumcenter of this triangle HGE. And therefore, point A is also the center of the circle that blocks triangle HGE. And again, this point A is the center of the circle that blocks triangle HGE. We know that very well that any circle that blocks triangle HGE must pass through its three vertices that are H, G, and E. So we know that we have here a circle that blocks triangle HGE that passes through point H, G, and E, and its center is located here at point A. But what is the radius of this of the circle that blocks triangle HGE? We know that the center of the triangle that blocks triangle HGE is here at point A. Triangle HGE, the circle that blocks triangle HGE must pass through point E. So point A is the center of the circle that blocks triangle HGE. Point E is the point on the circle that blocks triangle HGE. This is exactly the definition of a radius. Therefore, AE is the radius of the circle that blocks triangle HGE, and we already found out that AE equals to R. So we can summarize and say that the circle that blocks triangle HGE, its center is located here at point A, and its radius is R. That is from one side. But from the other side, if we complete this quarter circle to a circle, we will get a circle that its center is located here at point A, and its radius is R. Why? Because the radius of the quarter circle is R, therefore the radius of the circle must be also equal to R. So we have here two circles with the same center, that is A, and the same radius, that is R. Two circles with the same center, the same circle, they are not two circles, but they are the same circle. And therefore, the circle that we created by completing this quarter circle to a circle is also blocks triangle HGE, because it is the same circle. So the circle blocks triangle HGE, therefore it must pass through point H. Okay? So I will draw the circle that blocks triangle HGE, that is also the circle that will be created by completing this quarter circle to a circle. Repeat again that the circle must pass for point edge. So this is the circle that blocks triangle HGE, and it is also the same circle that will be created by completing this quarter circle by circle. So you have here line segment HAE. This is line segment HAE. Line segment HAE, it is absolutely a straight line. Why line segment HAE is a straight line? Because of the fact that angle HAE, this is angle HAE, equals to 180 degrees. Any angle that's equal to 180 degrees in its size is defined as a straight line. Therefore, HAE is a straight line, but HAE is a straight line that touches the circle at 2 points, E and H. Therefore, it is a chord. Any straight line that touches the circle at 2 points is defined as a chord. So we have chord HAE that passes through point A, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. And therefore, chord HAE is the diameter of this circle. If HAE is the diameter, also HE is the diameter, of course. So HE is the diameter of the circle. So write it down, HE, chord HE is the diameter of this circle. And we have here this is peripheral angle HGE. Again, this is peripheral HGE. Peripheral angle HGE is subtended on HE, on chord HE, that is the diameter of the circle. And any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, this peripheral angle HGE must be equal to 90 degrees. In the next step, we'll focus on quadrilateral ADGE. So we'll focus on this green quadrilateral ADGE. This quadrilateral ADGE this green quadrilateral ADGE, those two opposite angles, they are both right angles, and the sum of two right angles is of course 180 degrees. So inside the green quadrilateral ADGE we have two opposite angles that the sum of them is equal to 180 degrees. And we know that any quadrilateral that has two angles that the sum of them is equal to 180 degrees is a cyclic quadrilateral. That is to say, we can block this green quadrilateral ADGE by a circle. Okay, so we'll do it now. We'll block this quadrilateral ADGE by a circle. This red circle blocks this quadrilateral, this green quadrilateral ADGE. Why? Because of the fact that The red circle, this red circle passes through its four vertices that are A, D, G, and E. So we have the red circle that blocks this green quadrangle A, D, G, E. Here we can implement Rule 12. I repeat again on Rule 12. Rule 12 is true in any circle, so in any circle, if we have here two chords, chord AB and chord CD. The extended chord AB touches point B, and the extended chord CD also touches the same connection point P. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can definitely implement Rule 12 in our drawing. Why? Because of the fact that in our drawing, we have the red circle, and we have here, this is chord EA. The extended chord EA touches the connection point H, and here we have the extended chord GD. This is called GD, and the extended chord GD touches the same common example point H. So all the requirements of Rule 12 are satisfied, and therefore we can implement here Rule 12. Okay. According to Rule 12, the following equation will be true. That here we have edge A times edge E equals to edge D times edge G. Repeat again. According to Rule 12, if you focus on this red circle, the following equation will be true, that edge A times edge E equals to edge D times edge G. Edge A equals to 12, as you can see, the drawing, times edge E. What is times edge? It is edge G. But again, here edge A times edge E. Okay. Edge A is R. Okay. Edge A is R. Edge A is R. Times edge E. Edge E is the diameter of the circle, that is of course equals to 2R. So edge E is 2R. And it is equals to edge D. Edge D is 12 times edge G. What is the length of edge G? Edge G equals to edge D plus DG. Edge A is 12. DG is X, it is the variable that we are looking for in this question. So in total, edge G equals to 12 plus X. So actually, we found out that according to Rule 1, R times 2R equals to 12 times 12 plus X. This is equation 1. We divide this equation 1 by 2. and we get that according to equation 1, in this side of the equation we have r times 2r is 2r squared, and 2r squared over 2 is r squared. That equals to 12 over 2 is 6, so in total this expression equals to 6 times 12 plus x. Here we divide this equation 1 by 6, and get that according to equation 1, r squared over 6 equals to 12 plus x. Here we subtract 12 from this equation 1, and finally we get that according to equation 1, x equals to r squared over 6 minus 12. Okay, according to equation 1, we found that x equals to r squared over 6 minus 12. In the next step, we will implement the Pythagoras theorem on the right triangle ADE. On this right triangle ADE. The right green triangle ADE. So I copy this right triangle ADE in a new page, and we will implement on it the Pythagoras theorem. But before that, we define one side of this square ABCD is y. So AD equals to y, AB also equals to y, BC equals to y, and finally DC must be also equal to y according to our definition. So AD equals to y. What is AE? A equals to R. This is the radius of the quarter circle, that's equal to R. And it is given as the question that DE equals to 12 units in its length. So actually, this is the right triangle ADE, that is coming from the original drawing. Here, by PT, is a regression for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of this right triangle is DE, therefore the square of the hypotenuse is DE square, and it must be equal to AD square plus AE square. The hypotenuse DE is 12, therefore DE square is 12 squared, that is 144, and it is equals to AD square. AD is y, therefore AD square is y square plus AE. AE is r, therefore AE square is r square. In conclusion, we actually found out that according to equation 2, y square plus r square equals to 144. In the next step, we join points A and C together by a straight line. By joining points A and C, we created the right triangle ABC. So I copy this right triangle ABC in the new page, and we implement on this triangle ABC the Pythagoras theorem. Here by PT is the regression for Pythagoras theorem. What is the definition of line segment AC? Line segment AC starts from the center of the circle, that is actually point A, and ends at point C, that is the point on the circle itself. This is exactly the definition of a radius. Therefore, AC equals to R, that is the radius of this circle. AB equals to Y, it is 1 side of square ABCD. BC is also 1 side of square ABCD, that is also equals to Y. So actually, this is the right triangle ABC that I copied from the original drawing. Turn into the Pythagoras theorem, we get that in this right triangle ABC. This will be question 3. AC square equals to AB square plus BC square. Okay. AC is R, therefore AC square is R square. And it is equals to AB square. AB is Y, therefore AB square is Y square. Plus BC square. BC is also Y, therefore BC square is Y square. In conclusion, we shall find out that according to equation 3, R square equals to 2Y square. Here, we will divide this equation 3 by 2. And we get that according to equation 2, Y square equals to R square over 2. This is actually equation 3. According to equation 3, Y square equals to R square over 2. While according to equation 2, we already found out that 144 equals to Y square plus R square. Now we can substitute Y square in this equation 2 by R square over 2 from equation 3. We'll do it now, and we get that according to equation 2, 144 equals to Y square is R square over 2 plus R square. Here we'll multiply R square by 2 and then we'll divide it by 2 in order to have a common factor with R square over 2. And we'll get that according to equation 2, 144 equals to, in the numerator we'll have R square plus 2R square because we multiplied R square by 2 divided by 2. So according to equation 2, we actually found out that 144 equals to R square plus 2R square is 3R square over 2. Here we'll multiply this equation 2 by 2. And finally we get that according to equation 2, 2 times 144 is 288, that equals to 3R square. Here we'll divide this equation 2 by 3. And finally we get that R square equals to 288 over 3 is 96. So I found out actually that R square equals to 96. According to equation 2, R square equals to 96. While according to equation 1, we have already found out that x equals to R square over 6 minus 12. And again, according to equation 1, x equals to R square over 6 minus 12. Now we can substitute R square in this equation 1, by 96 from equation 2. We'll do it now and we get that x equals to Here r squared is 96, so this expression total equals to 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 4. So if you found out that x equals to 4, x, it is actually the length of this line segment GD, or DG. So the length of line segment DG is equal to x equals to 4 units. And that is the answer to our question. So in the next step, we'll find out the length of this line 17G according to the second method. First of all, we know that all the angles inside square ABCD are right angles. So this angle equals to 90 degrees in its size. This angle also equals to 90 degrees. This angle equals to 90 degrees. And finally, this angle also equals to 90 degrees in its size. In square ABCD, the opposite sides, of course, parallel to each other. That is to say, side DC is parallel to side AB. And again, in square ABCD, side DC is parallel to side AB. But AB is part of the straight line AE and is parallel to DC. If part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, AE must be also parallel to DC. AE must be also parallel to DC. Here we have the rule that the opposite alternating angles between parallel lines are equal to each other. Those two angles are defined as alternating angles, and they are located between the parallel lines DE and AE, and therefore they are equal to each other. But this angle equals to theta, therefore this angle must be also equal to theta. Repeat again. Those two angles are equal to each other according to the rule that alternating angles between parallel lines are equal to each other. Those two alternating angles that are located between the parallel lines DC and AE must be also equal to each other. So if this angle is theta, then this angle must be also equal to theta because they are equal to each other. Okay. In the next step, we'll do a construction. That is to say, from point G, we will do perpendicular on AB. Repeat again, from point G, we will do perpendicular. We will draw perpendicular on AB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. We define the intersection point between perpendicular GN and side DC of the square by M. by doing this construction, we get the quadrilateral DMAN. Inside quadrilateral DMAN, we have 1, 2 free right angles. The sum of free right angles is 270 degrees. Therefore, this fourth angle must be also equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral DANM to 360 degrees, this missing angle must be also equal to 90 degrees in its size. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Likewise, this quadrilateral MCBN, we have 1, 2 free angles, therefore this fourth angle must be also equal to 90 degrees in its size according to the sum rule. So we focus on the left side of the perpendicular GN. GN is a perpendicular, it is absolutely straight line. So we focus on the left side of the straight line GN at point M. The left side of GN is point M. The sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the left? At the left side of GN is point M, we have this angle that is 90 degrees, plus this missing angle. In total, the sum of those angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles on the left side of the straight line GN at point M to 180 degrees, the missing angle must be equal to 90 degrees in its size. So, we have here the right triangle DGM. I will copy this right triangle GM in a new page and we'll analyze it. The hypotenuse DG equals to x according to what is given us the question. X is the variable that we are looking for in this question. So actually, this is the right triangle DGM that I copied from the original drawing. In this triangle DGM, it is very clear to see that cosine theta equals to dm over dg. So cosine theta equals to dm over dg. G is x, so it is dm over x. In conclusion, we actually found out that according to equation 1, cosine theta equals to dm over x. We will multiply this equation 1 by x, and we get the dm equals to x times cosine theta. But again, according to equation 1, we found out that dm equals to x times cosine theta. In the next step, I'll copy this right triangle ADE in a new page and we'll analyze it. we define one side of this square ABCD as y. Therefore, all the four sides must be, of course, equals to y. So here, AB equals to y, CB equals to y, and DC also equals to y. We already found out that AE, actually AE is the radius of the quarter circle. Why? Because it starts from point A, that is the center of the quarter circle, and ends at point E, that is the point of the quarter circle itself. Therefore, AE is the radius of this quarter circle. We'll define the radius of the quarter circle as R, therefore AE equals to R. And DE equals to 12 units in its length according to what is given as the question. So actually, this is the right triangle ADE that are coming from the original domain. In this right triangle ADE, cosine theta equals to AE over DE. Cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. In conclusion, we found out that cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. Now we can substitute cosine theta in this equation 1, by R over 12 from this equation 2. We'll do it now, and we get that dm equals to x times cosine theta, and cosine theta is R over 12 according to equation 2. In conclusion, we should found out that dm equals to xr over 12. dm equals to xr over 12. Yeah. This side dm or line segment dm equals to xr over 12. But because of the fact that dm an is a quadrilateral with four right angles, and any quadrilateral that has four right angles must be this rectangle plus a square, so we'll relate to this quadrilateral dm an as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say in the rectangle dm an, side dm equals to side an, but dm equals to xr over 12, therefore an must be also equal to xr over 12. Likewise, according to the sum rule, in the same rectangle ADM and side DA must be equal to the opposite side MN, but DA equals to Y, therefore MN must be also equal to Y, because they are equal to each other. So in the next step, we will return to our right triangle DGM. So I'll copy this right triangle DGM again, and we'll analyze it. So actually, this is the right triangle TGM that I copied from the original drawing. In this right triangle DGM, it is very easy to see that sinus theta equals to GM over DG. Sinus theta equals to GM over DG. So sinus theta equals to GM over DG. DG is X. This is the variable that we're looking for in this question. So if we're going to actually find out that sinus theta equals to GM over X, here we'll multiply this equation 1 by X, and finally we get that GM equals to X times sinus theta. According to equation 2, GM equals to X times sinus theta. We return again to the right triangle ADE, so I copy the right triangle ADE and we'll analyze it. AE equals to R, it is the radius of the circle. AD equals to Y, and the hypotenuse D equals to 12. This is angle theta. So actually, this is the right triangle ADE that I copied from the original drawing. In this right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. So sinus theta equals to AD, that is Y, over DE, that is 12. So in conclusion, we actually found out that sinus theta equals to Y over 12. Okay. Sinus theta equals to Y over 12. But according to equation 2, we have already found out that GM equals to X times sinus theta. So now we can substitute sinus theta in this equation 2 by Y over 12 from this equation. So sinus theta equals to Y over 12. We'll do it now. We'll get that GM equals to X times sinus theta. Sinus theta is Y over 12. So in conclusion, according to equation 2, we found out actually that GM equals to X times Y over 12. This is GM equals to XY over 12. In the next step, we will join points A and G together by a straight line. By joining points A and G, we created the right triangle AGN. So I copy this right triangle AGN and we manipulate on this right triangle the Pythagoras theorem. What is the definition of line segment AG or the hypotenuse AG? The hypotenuse AG starts from point A, that is the center of the circle, of the quarter circle, and ends at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG equals to R. It is the radius of the quarter circle that is equal to R according to our definition. We have already found out that AN equals to X times R over 12. And what is the length of this line segment? Line segment GN. Line segment GN equals to GM plus MN. That is to say, line segment GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. Here by PT is the relation for Pythagoras theorem. So actually, this is the right triangle AGN that I commit from the original drawing. This right triangle AGN, according to the Pythagoras theorem, we get that AG squared equals to AN squared plus GN squared. AG is R, therefore AG squared is R squared, and it is equals to AN squared. AN is X over 12, therefore AN squared is X squared times R squared over 12 squared, that is 144, plus GN squared. GN is Y plus XY over 12, therefore GN squared is Y plus XY over 12 squared. Here we take out y as a common factor for this expression, and we get that according to equation 1, r squared equals to x squared times r squared over 144. And we have this expression, we take y as a common factor. So inside the brackets, what is left from y after we took from it y as a common factor? What is left is actually 1 plus what is left from the expression xy over 12 after we took from it y as a common factor. What is left is actually x over 12. All squared. Here we open the brackets of this expression, and we get that according to this equation 1, r squared equals to x squared times r squared over 144 plus, here we will open the brackets and we get y squared, and here we have 1 plus x over 12 also squared. Here we multiply 1 by 12 and then we divide it by 12 in order to have a common factor with x over 12, and we get that according to equation 1, r squared equals to x squared times r squared over 144 plus y squared. Here the numerator will have 12 because we multiply 1 by 12. 12 plus x over 12 squared. We have here the algebraic identity that states that a over b squared is equal to a squared over b squared. We use this algebraic identity here in this expression, and we get that this expression will be equal to 12 plus x squared over 12 squared, according to this algebraic identity. So here we have r squared equals to x squared times r squared over 144 plus y squared, and here this expression according to this algebraic identity will be equal to 12 plus x squared over 12 squared, that is 144. Okay. In the next step, we join points A and C together by straight line. By joining points A and C, we create the right triangle, triangle ABC. So copy this right triangle, triangle ABC in a new page, and we implement on this right triangle ABC the Pythagoras theorem. What is the definition of the hypotenuse AC, or line segment AC, or the hypotenuse AC? There's another definition because the hypotenuse AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R according to our definition. AB is one side of square ABCD, that is Y. BC is also one side of square ABCD, that is Y. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle ABC that I copied from the original drawing. This right triangle ABC, according to the Pythagoras theorem, this will be equation 2, according to the Pythagoras theorem, AC squared, this is point C, AC squared equals to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and it is equal to AB squared. AB is Y, therefore AB squared is Y squared, plus BC squared. BC is also Y, therefore BC squared is Y squared. So according to equation 2, we actually found out that R squared equals to Y squared plus Y squared, that is 2Y squared. This is according to equation 2. When according to equation 1, we have already found out that R squared equals to X squared times R squared over 144 plus Y squared times 12 plus X squared over 144. Here we will divide this we will substitute r squared in this equation 1 by 2y squared, because according to equation 2, r squared equals to 2y squared. So here we have, according to equation 1, r squared, so it is 2y squared, and it equals to r squared, that is 2y squared according to equation 2, times x squared over 144 plus y squared times 12 plus x squared over 144. Here we divide this equation 1 by y squared, and we get that according to equation 1, two y squared over y squared is 2, and it is equals to here y squared will get cancelled, and we're left only with 2x squared over 144 plus here y squared also will get cancelled, and we're left only with 12 plus x squared over 144. In conclusion, according to equation 1, found out actually that 2 equals to 2x squared plus 12 plus x squared over 144. Here we multiply this equation 1 by 144, and we get that according to equation 1, 2 times 144 is 288, it equals to, here 144 in the denominator will get cancelled, and we left only with 2x squared, plus here 144 in the denominator will get cancelled, and we left only with 12 plus x squared. So here we open the brackets on this side of the equation 1, and we get that 288 equals to 2x squared plus 12 plus x squared equals to 12 squared, that is 144 plus x squared plus 2 times 12x is 24x. Here we have 288, that is equals to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we substitute 288 from this equation 1, and we get that according to equation 1, we have 3x squared plus 24x, and 144 minus 288 equals to minus 144 is equals to 0. Here we'll divide this equation 1 by 3, and we get that according to equation 1, 3x over 3 is x squared, 24x over 3 is 8x, minus 144 over 3 is minus 48, that is equals to 0. So this is a quadratic equation. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. This is the general formula. A, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. We find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 40x equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So we put the values of a, b, and c for our specific quadratic equation, those three values inside this general formula for x, in order to find out the value of x in our specific quadratic equation. I remind you that x is the variable that we are looking for. In this question, x is the length of line 7 dg, that is equal to x. Or x is equal to the length of line 7 dg. Okay. So here, we do it now. We put the values of a, b, and c in this general formula in order to find out the value of x for our specific quadratic equation. So x equals to minus b. B is 8, therefore minus b is minus 8, plus minus square root of b squared. B is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. And minus 4, and c is minus 48. So minus 4 times ac in total is minus 4 times minus 48, that is plus 192 over 2a. A is 2, so 2a is 2 times a is 1, therefore 2 times a is 2 times 1, that is 2. So in conclusion, actually found out that x equals to minus 8 plus minus, and inside this, the root we have 64 plus 192 is 256. So inside the root we left only 256 over 2. So in conclusion, I actually found out that x equals to minus 8 plus minus square root of 256 over 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. One of those two solutions, it is a negative solution because minus 8 minus 16 definitely a negative number. And because of the fact that x is the length of this line 7 dg, x is a length, it must be a positive number. Therefore, the negative solution is irrelevant, incorrect solution, and we take into account only the positive solution for x. And the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. If we found out that x equals to 4 units in its length. X is the length of this line 7 dg. So dg is equal to x is equal to 4 units in its length. We finish with the second method. In the next step, I'll summarize the lecture. We start with the first method, of course. Okay, again on the question. In the drawing, we have a quarter circle. Inside this quarter circle, we have square ABCD. We know that this is 170 that is equal to 12 units in its length. This is angle theta, that is angle GDC. And this is also angle theta, that is angle CDE. Our mission is to find out the length of this 170 that is equal to x. So in the first method, we actually know that all the angles inside square ABCD are right angles, so those four angles are all right angles. So what is the size of this angle? This angle equals to the big angle that is 90 degrees minus angle theta. So this angle ADE equals to 90 degrees minus theta in its size. And in the next step we actually extended line segment GD and line segment EA by straight line until they touch each other. And we define the touching point, this point, as H. And we extended line segment CD or side CD of square BCD by straight line, define this point as F. Those two angles are peripheral angles, and we know that peripheral angles are equal to each other. But this is angle theta, therefore this angle must be also equal to theta because those two angles are equal to each other. And CD is a straight line, and you extended the straight line CD by straight line, and therefore the result CF is also a straight line. If you focus on the lower side of the straight line CF at point D, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of CF at point D? We have this angle that is 90 degrees, plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to the size of the big angle that is 90 degrees minus theta. So this angle also equals to 90 degrees minus theta in its size. So here we have, if you focus on the upper side of the straight line E edge at point A, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of E edge at point A? We have this angle that is 90 degrees plus the missing angle. In total it must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. So in the next step we actually proved that those two right triangles can go into each other. This is to say the right triangle ADH is congruent to this right triangle ADE. So why those two right triangles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, DA is a common side that belongs to both triangles, so we can write down that DA equals to itself is a common side that belongs to both triangles. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually proved that those two right triangles can go into each other according to angle side angle rule. What is angle side angle rule? Angle side angle rule is that if you prove that two angles in the side that included between the two angles in one triangle are correspondingly equal to two angles in the side that included between the two angles in the second triangle, then you actually prove that those two right triangles can go into each other according to angle side angle rule. And we actually proved that those two angles in the side that included between those two angles, that is side DA, the right triangle ADE, are correspondingly equal to those two angles in the side that included between those two angles, that is also side DA, the same side, in the right triangle ADH. Therefore, we actually proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles, those two corresponding sides, that is to say side DE and side DH, must be also equal to each other. But DE equals to 12, therefore DH must be also equal to 12. We know that AE is the radius of this quarter circle, therefore we define the radius as R, therefore A equals to R. And again, because of the fact that those two right triangles can go into each other, side AE in the right triangle ADE equals to side HA in the right triangle ADH, according to the sum rule that corresponding sides in congruent triangles are equal to each other. But AE equals to Y, therefore AH must be AE equals to R, therefore AH must be also equal to R. Okay. In the next step, We join points E, G and E together by straight line. By joining points G and E, we created triangle EGH. In the next step, we join point G and A together by straight line. We join point G and A together by straight line. What is the definition of line segment AG? Line segment AG starts from the center of the quarter circle or circle and ends at point G, that is a point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AG equals to the radius of this quarter circle, that is equal to R. And point A is the circumcenter of this triangle HGE. That is to say, point A is located in the same distance from all the three vertices of this triangle HGE. The distance between point A and the vertex edge is R. The distance between point A and the vertex C of triangle HGE is also R. And the distance between point A and the vertex G of triangle HGE is also R. For that reason, point A is defined as the circumcenter of triangle HGE. But point A is also the center of the circle that blocks this triangle HGE. So we know that point A is the center of this circle that blocks triangle HGE, and any circle that blocks triangle HGE must pass for its three vertices, that is H, G, and E. So we know that we have here a circle that blocks triangle HGE, that is passes for point H, G, and E, and its center is here at point A. What is the radius of that circle that blocks triangle HGE? The radius is defined as the line that starts from the center of the circle. In this case, the center of the circle that blocks triangle HGE is here at point A. And we have point E, that is also a point that the circle that blocks triangle HGE must pass for it. And therefore, AE, this is exactly the definition of a radius. AE is the radius of the circle that blocks triangle HGE, is equal to R. So we have a circle with center A and radius R that blocks triangle HGE, that passes for point H, G, and E. That is from one side. But from the other side, if we complete this quarter circle AFE to a circle, like we did here, we'll get a circle that its radius is R and its center is A. So we have two circles with the same radius R and the same center A. The circle that blocks triangle HGE is also with radius R and center A. Those two circles are not two circles but one circle. Because if you have two circles with the same radii and the same center, they are not two circles but one circle. That is to say, if we complete this quarter circle to a circle, we will get a circle that also blocks triangle HGE. And because of the fact that it blocks triangle HGE, it must pass for its three vertices this vertex H. It must pass for its three vertices that includes also vertex H of triangle HGE. So this circle that is created by completing this quarter circle to a circle must pass for point H, that is one vertex of triangle HGE. Okay, so what is the definition of line segment HAE? First of all, line segment HAE is definitely a straight line because of the fact that this angle equals to 180 degrees. Any angle is equal to 180 degrees, it is defined as a straight line. So HAE is a straight line but it is a straight line that touches the circle at 2 points, H and E. Any straight line that touches the circle at 2 points is defined as a chord. So we have here chord edge AE, but chord edge AE passes through point A, that is the center of this circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, edge A is the diameter of the circle. If edge A is the diameter of the circle, edge E is also, of course, the diameter of the circle. In conclusion, you can say that edge E is the diameter of the circle. And because of the fact this peripheral angle edge GE, peripheral angle edge GE, is subtended on edge E, that is the diameter of the circle, we know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in size. Therefore, this peripheral angle must be equal to 90 degrees. So, peripheral angle G equals to 90 degrees in size. In the next step, we actually focused on this green quadrilateral GDAE. This side, this green quadrilateral, we have those two opposite angles. They are both right angles. So inside this quadrilateral ADGE, we have two opposite angles, and the sum of those two opposite angles equals to 180 degrees. Any quadrilateral that the sum of its two opposite angles is equals to 180 degrees, it is a cyclic quadrilateral. That is to say, we can block this green quadrilateral ADGE by a circle. We actually plugged this green quadrilateral by this red circle. That is to say, this red circle passes through its four vertices DG, EA of this quadrilateral ADGE. Okay, so now we can implement here rule 12. What is rule 12? According to rule 12, if we have here a circle and we have inside this circle two chords, chord BA and chord DC, and the extended chord BA touches the common external point P, and the extended chord CD also touches the same common external point P. So in this moment, the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule 12 in our drawing. Why? Because in our drawing, we have the red circle. Inside this red circle, we have this chord GD. The extended chord GD actually touches the common external point H, and we also the extended chord EA. This extended chord EA touches also the same common external point H. So all the requirements of rule 13 are satisfied, and therefore we can implement it rule 12. According to rule 12, the following equation will be true, that edge A times edge E equals to edge D times edge G. Again, edge A times edge E equals to edge D times edge G. Repeat again, according to rule 12, edge A times edge G equals to edge D times edge G. Edge A is R, edge E is the diameter of the circle, that is 2R. Repeat again, edge A is R, edge G is 2R, edge D is 12, and edge G in total equals to 12 plus X. Repeat again, edge D is 12 and edge G is 12 plus X. So in conclusion, we found out that R times 2R equals to 12 times 12 plus X. Here we divided this equation 1 by 2, and finally found out that here R times 2R is 2R squared, 2R squared over 2 is R squared. Here 12 over 2 is 6, so in total this expression equals to 6 times 12 plus X. We divided this equation 1 by 6, and finally found out that R squared over 6 equals to 12 plus X. Here we subtracted 12 from this equation 1, and finally found out that X, according to equation 1, X equals to R squared over 6 minus 12. This is according to equation 1. Then I copied this right triangle ADE in this new page, and we implemented the Pythagoras theorem on this right triangle, triangle ADE. This is the right triangle ADE that I copied from the original drawing. Side AD is one side of square ABCD that is y according to our definition. DE equals to 12 units in itself according to what is given in the question. We already found out that AE is the radius of this quarter circle that is equal to R. A equals to R. In this right triangle ADE, according to the Pythagoras theorem, DE square equals to DA square plus AE square. Again, DE square equals to AD square plus AE square. DE is 12, therefore DE square is 12 squared, that is 144, and is equals to AD square. AD is y, therefore AD square is y square, plus AE square. AE is r, therefore AE square is r square. So in conclusion from equation 2, we actually found out that 144 equals to y square plus r square. This is according to equation 2. In the next step, we join points A and C together by straight line. By joining points A and C, we created the right triangle, triangle ABC. So I copied this right triangle ABC in the new page, and we implemented this right triangle ABC, the Pythagoras theorem. This is the right triangle ABC that I copied from the original drawing. AC, the bottom of AC starts from point A, that is the center of the circle, and then at point C, that is the point of the circle itself. This is exactly the definition of radius. Therefore, AC is the radius of this circle that is equal to R. BC is one side of square ABCD that is Y. AB is also one side of square ABCD that is also Y. So in this right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equal to AB square. AB is Y, therefore AB square is Y square, plus BC square, BC is Y, therefore BC square is Y square. So in conclusion, we found out that R square equals to Y square plus Y square, that is 2Y square. So according to equation 3, we actually found out that R square equals to 2Y square. We divided this equation 3 by 2, and finally found out that according to equation 3, y square equals to r square over 2. This is according to equation 3. While according to equation 2, we have only found out that 144 equals to y square plus r square. Now we can substitute y square on this equation 2, by r square over 2 from this equation 3. We did it and found out actually that according to equation 2, 144 equals to y squared, that is r square over 2 plus r square. Here we multiplied r square by 2 and then we divided by 2 in order to have a common factor of r square over 2. And finally found out actually the numerator of this expression we have in total r square plus 2r square divided by 2. So we actually found out that r square equals to r square plus 2r square over 2. R square plus 2r square is 4r square, so we found out that according to equation 2, 144 equals to 3r square over 2. Here we multiplied this equation 2 by 2, and finally found out that 144 times 2 is 288, that is equals to 3r square. Here we divided this equation 2 by 3, and finally found out that r square equals to 288 over 3, that is 96. So actually according to equation 2, we actually found out that r square equals to 96, while according to equation 1, we have already found out that x equals to r square over 6 minus 12. Now we can substitute r square in this equation 1 by 96 from equation 2. We did it, and actually found out that x equals to r squared, that is 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 4. So actually found out that then from this line 7 dg, that is equal to x is equal to 4 units. We finished with the first method. In the next step, I actually presented to you the second method. First of all the angles inside this square ABCD are right angles. Those 4 angles, they are all right angles. in any square, the opposite sides are parallel to each other, especially it is true in square ABCD. In square ABCD, side DC is parallel to the opposite side AB. DC is parallel to AB. But AB is part of the straight line AE. Again, AB is part of the straight line AE and it is parallel to DC. So if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, the straight line AE itself must be also parallel to DC. Okay, AE must be also parallel to DC. So we know that AE is parallel to DC. Those two angles are defined as alternating angles and they are located between the parallel lines DC and AE. And you know that alternating angles between parallel lines are equal to each other. Again, according to the rule that alternating angles between parallel lines are equal to each other, those two angles must be equal to each other. But this angle is theta, therefore this angle must be also equal to theta. Okay. In the next step, we did a construction. That is to say, from point G, we drew perpendicular on AB. Again, from point G, we drew perpendicular on AB. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. We define the intersection point between perpendicular GN and side DC of the square by M. So, by doing this construction, we created here quadrilateral DMNA. In quadrilateral DMNA, we have 1, 2, 3 angles. Therefore, this fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. If we focus on the left side of GN, GN is perpendicular. GN is perpendicular, it is absolutely a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. So we have here the right triangle DMG. So I copied this right triangle DMG and we analyze it. This is the right triangle DMG that I copied from the original drawing. This is angle theta. This angle equals to 90 degrees according to what we have already proved. dg equals to x. X is the variable that we are looking for in this question. We have to find out the length of the product dg that is equal to x according to what is given as the question. So in this right triangle DGM, it is very easy to see that cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. dm is the missing side, so we leave it as it is, and dg equals to x according to what is given as the equation. So in conclusion, we have known that according to equation 1, cosine theta equals to dm over x. We multiplied this equation by x, and finally found out that dm equals to x times cosine theta. Again, according to equation 1, dm equals to x times cosine theta. Then I copied this right triangle ADE in the new page and analyze it. This is the right triangle ADE that I copied from the original drawing. According to our definition, AD and AE, they are both on the sides of square ABC. AD is one side of square ABCD that is equal to y according to our definition. And AE is the radius of the quadricycle that is equal to r. Again, AE equals to r and D equals to 12 according to what is given as the question. So, and this is angle theta. We proved that this is angle theta according to the rule that alternating angles between parallel lines are equal to each other. So this is angle theta. So in this right triangle ADE, cosine theta equals to AE over DE. Okay, AE is R and DE is 12. So in conclusion, we should have found out that according to equation 2, cosine theta equals to R over 12. Well, according to equation 1, we have already found out that dm equals to x times cosine theta. Now we can substitute this cosine theta, this equation 1, by r over 12 in this equation 2. We did it, and we actually found out that dm equals to x and cosine theta is r over 12. So dm in total equals to x times r over 12. This is 97 dm, this is equal to x times r over 12. But we know that quadrilateral DMAN with 4 right angles is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So side DM must be equal to the opposite side AN. But DM is XR over 12, therefore AN must be also equal to XR over 12. Okay. The next step, return to this right triangle DGM. So I copy this right triangle DGM. This new page. This is the right triangle DGM that I copied from the original drawing. In this right triangle, it is very easy to see that sinus theta equals to GM over DG. So sinus theta equals to GM over DG. DG is x, so substitute DG by x. So in conclusion, we found out that sinus theta equals to GM over x. We multiplied this equation 1 by x. And finally, we found out that GM equals to x times sinus theta. Okay, GM equals to x times sinus theta. This is according to equation 1. Then we return to equation to the right triangle ADE. So I copy this right triangle ADE here. In this right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. Sinus theta equals to AD over DE. AD is y, it is one side of square ABCD, over DE. DE is 12 according to what is given as the equation. So in conclusion, I should have found out that according to equation 2, sinus theta equals to y over 12. And according to equation 1, we found out that GM equals to x times sinus theta. Now we can substitute this sinus theta in this equation 2 by y over 12. From this equation can substitute sinus theta from this equation 1, in this equation 1 by y over 12 from this equation 2. We did it and found out that GM equals to x and sinus theta is y over 12. So in conclusion, we actually found out that GM equals to xy over 12. Here, GM equals to xy over 12. And here we have rectangle DM and A. In rectangle DM and A, the opposite sides are equal to each other. That is to say, side DA must be equal to the opposite side MN, but DA is y, therefore MN must be also equal to y. Then we join points A and G together by a straight line. What is the definition of the hypotenuse AG? The hypotenuse AG starts from the center of the quarter circle, that is point A, and ends at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equal to R. Then I copied this right triangle AGN in a new page, and we implemented on this right triangle AGN the Pythagoras theorem. This is right triangle AGN that I copied from the original drawing. We just right now found out that the hypotenuse AG equals to R, this is the radius of the quarter circle. What is the length of GN? GN equals to GM plus MN. That is to say, GN equals to GM, that is xy over 12, plus MN, that is y. So in total, GM equals to xy over 12 plus y. Again, Gn in total equals to xy over 12 plus y. And we already found out that an equals to xr over 12. An equals to xr over 12. Here we implemented the Pythagoras theorem in this right triangle AGN. According to the Pythagoras theorem in this right triangle AGN, AG square equals to AN square plus GN square. Again, AG square equals to AN square plus GN square. AG is y, therefore AG square is y. AG is r, therefore AG square is r square. And it is equals to AN square. AN is y plus xy over 12, therefore AN square, and therefore GN square is y plus xy over 12 square. Okay, plus AN square. AN is x over 12, therefore AN square is x square times r square over 12 square, that is 144. So according to equation 1, we actually found out that r square equals to x square times r square over 144 plus y plus xy over 12 square. Here we took y as a common factor from this expression. We actually found out that according to equation 1, r square equals to x square times r square over 144, and we took y as a common factor from this expression. So what is left from y after we took from it y as a common factor? What is left? It's actually y 1. And what is left from xy over 12 after we took from it y as a common factor? What is left is actually x over 12. So here, then we open the brackets here and found actually that r square equals to x square times r square over 144. After we open the brackets here, we found here that is equals to y square plus 1 over x over 12 square. And here we have r squared that is equal to x squared times r square over 144 plus r square, and we have here 1 plus x over 12. Here we multiplied 1 by 12 and then we divided by 12 in order to have a common factor with x over 12. So totally the numerator will have 12 plus x divided by 12 squared. Here we used the algebraic identity that a over b square equals to a square over b square. According to this algebraic identity, 12 plus x over 12 square will be equal to 12 plus x square over 12 square, that is 144. So in conclusion, we found out that according to equation 1, r square equals to x square times r square over 144 plus y square times 12 plus x square over 144. Then we joined points A and C together by straight line. By joining points A and C, we created the right triangle, triangle ABC. Then I copied this right triangle ABC and implemented on this right triangle ABC the Pythagoras theorem. Here by PT is the information for Pythagoras theorem. We already found out that AC is the radius of the circle, that is R. AB is one side of square ABCD, that is Y according to the definition. BC is also one side of square ABCD, that is Y. So in this right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equal to AB square. AB is Y, therefore AB square is Y square plus BC square. BC is also Y, and therefore BC square is Y square. So in conclusion, we found out that R square equals to Y square plus Y square, that is 2R square. So R, according to equation 2, R square equals to 2Y square. This is according to equation 2. Well, according to equation 1, we already found out that R square equals to X square times R square over 144 plus Y square times 12 plus X square over 144. Now we can substitute R square in this equation 1 by 2Y square from this equation 2. And we did it, and we found out actually in equation 1 we have R square, that is 2Y square according to equation 2, that is equals to, here R square is 2Y square times X square over 144 plus Y square times 12 plus x squared over 144. Here we divided this equation 1 by y squared. So here y squared will get cancelled, here y squared will get cancelled, and here y squared will get cancelled. After we cancel y squared and this equation 1, we left only with 2y squared over y squared is 2. And so we left with 2, that is equals to 2x squared over 144 plus 12 plus x squared over 144. Here we multiply this equation 1 by 144, and we found out actually that 2 times 144 is 288. This equals to 2x squared. Here 144 in the denominator will get cancelled because we multiply this equation by 144 plus 12 plus x squared. Here also 144 in the denominator will get cancelled. So according to equation 1, 288 equals to 2x squared plus 12 plus x squared. Here we open the brackets on this side of the equation, on this expression 12 plus x squared, and found out actually that according to equation 1, 288 equals to 2x squared, and here 12 plus x squared equals to 12 squared, that is 144, plus x squared, plus 2 times 12x, that is 24x. Here we have 288, that is equals to 2x squared plus x squared, that is 3x squared, plus 24x, plus 144. Here we subtracted 288 from this equation 1, and we found out actually that 3x squared plus 24x, and then we have 144 minus 288 is equals to minus 144 is equal to 0. So according to equation 1, we actually found out that 3x squared plus 24x minus 144 equals to 0. Here we divided this equation 1 by 3, and finally found out that x squared plus 8x minus 48 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So now we have to put the values of a, b, these values a, b, and c that we found for our specific quadratic equation in order to find out the value of x in our specific quadratic equation. X is the variable that we are looking for. In this question, x is the length of this line 7 dg. So we did it, we put the values of a, b, and c, those values, inside the general formula for x in order to find out the value of x in our specific quadratic equation. So we found out actually that x equals to minus b. B is 8, therefore minus b is minus 8, plus minus square root of b squared. B is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is minus 48. And minus 4 times 48 is plus 192. So inside the root we have 64 plus 192. So x equals to minus 8 plus minus square root of 64 plus 192 over 2. 64 plus 192 is 256. So inside the root we left only with 256. And we actually found out that x equals to minus 8 plus minus square root of 256 over 2. And x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. One of those two solutions are a negative solution, and because of the fact that x is the length of this line 7 dg, it cannot be negative, it must be a positive number. So we will cancel this solution, the negative solution, and we'll take into account only the positive solution for x. And the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. In conclusion, we found out that the length of this line segment DG that is equal to x is equal to 4 units. Okay, thank you very much.